Okay, we've spent so far most of the course talking about a couple different statistical procedures on the heels of reviewing the stuff that we did in the 7810, the educational statistics course. And the procedures that we've done, the first one was we extended correlation to be able to use those correlations to make predictions based on, first of all, one predictor or one variable, one independent variable specifically, and then we expanded that to be able to make predictions and factor in a bunch of predictors or a bunch of a bunch as in more than one. And then the other thing we did was we extended what we learned about ANOVA or analysis of variance. And remember, an analysis of variance, a simple analysis of variance, or a one-way ANOVA, is where you've got typically 3 groups or more. You can do it with 2, but usually more than 2. But if you've got 3 groups and you've got data sets of each of those 3 groups, it could be test scores from Miss Jones' class, Miss Johnson's class, and Miss White's class. So you've got a bunch of scores for each of 3 groups, and the question is each of those groups, each of those classes has an average score, whatever the average test score is. The question ANOVA will answer is any mean from a single class different from any other mean from another class? That's what ANOVA is. Now, we expanded that to a two-way ANOVA. It's still univariate analysis, but it's a two-way ANOVA because what we've done, we've added a variable, but we've added an independent variable. So I might want to look at the test averages of those scores, comparing the classes to each other, but also maybe breaking it down into looking at boys and girls separately. So we would use gender as an additional independent variable. It's still univariate, but again, as we've mentioned a couple of times, multivariate means something else, and we're about to talk about what that is. I told you we'd talk about it, now we're talking about it. Okay, so let's go back and look at a one-way ANOVA, just a single independent variable for now, but instead of adding an additional independent variable, let's add an additional dependent variable. And that's what makes it multivariate. So whether it's unit or multivariate depends on the number of dependent variables you have. If you add an additional independent variable, it's still univariate, but it's a two-way, or you can have a three-way, or a four-way, five-way, or however many you want to get in there, but you can imagine the interactions of those main effects are going to get really, really, really messy once you add more than a couple of independent variables together. But adding a dependent variable makes it multivariate. So let's look at an example. If you will turn in Green and Salkin, we're not going to use Whit and Whit now because we're kind of past Whit and Whit. But Green and Salkin does a pretty good job in giving us some examples of applications of multivariate analysis. So specifically lesson 28, and in what edition am I using? The 6th edition, looking at lesson 28, begins on page 222. 222 is entitled One-Way Multivariate Analysis of Variance. Now, if you're thinking about what that looks like, let's see if I can write this on the screen or not. I don't know if I can. Let's try. We abbreviated ANOVA as ANOVA. A multivariate ANOVA is abbreviated as Manova, M-ANOVA, M-A-N-O-V-A. That means there's more than one dependent variable. Yes, feel free to make whatever jokes you want to about that. It can get worse, as you'll see soon. Okay, so far so good. We're adding a dependent variable. Matter of fact, I even wrote, just so I'll make sure I remember to say it this way, at the top of my book on page 222, more than one dependent variable. I underlined the DE. Stop that. Okay, so if you will call up the data for that, and we'll start with data set 1. Is that what it's called? Let me get that on the screen for you. Now you have to look at me only once. Lesson 28, Data File 1. And I believe, actually, you still get to see me twice. And the scenario is laid out at the bottom of page, the last fourth or so of page 222. I will make one edit on what they say at the very end because they don't do exactly what they said, but they make it actually a little easier. Okay, so we're basing our groups on writing conditions. We have 3 groups. So, there's 30 students from different sections of an Intro to Psychology course were randomly assigned to one of 3 study conditions: the think condition, the write condition, or the talk condition. Don't know what those mean exactly, but I don't care. They just label the 3 groups. One condition emphasizes thinking, I assume, one emphasizes writing, and one emphasizes talking. So they receive different instructions on how to study. You talk about it, you think about it, you write about it. And after they go through this treatment, they're going to take a quiz. And it's those quiz scores that we want to compare. Well, so far that sounds like a plain old ANOVA, and it is so far. However, the quiz is going to give us not just a single score, but it's going to give us more than one score. Now, they specifically mention at the end of it, they say 4 dependent variables. Our data set only includes 2 dependent variables, but that's still enough to make it multivariate. So we're going to get scores on how well they recall and how well they apply. So we've got 2 outcomes. And those variables are defined probably considerably better than I just did at the top of page 225. And the research questions, again, they phrase those a couple different ways. I like the way they put it first. Are the population means for the scores on recall and application tests the same or different for students in the 3 categories? Is there any difference in recall scores from one group, any group to another, or is there any difference on application scores from one group to another? So we've got 2 different comparisons to make because we've got 2 different outcomes, 2 different dependent variables. So far, so good? 225 is where the 225 is where they define the variables and articulate the research question. Okay? Any other questions before we jump into this? Generally, it behaves the way you think it would. There are a couple of twists. Just a couple of adjustments we have to make because we're adding dependent variables. So you'll see. So first of all, we're going to go to Analyze, and we're going to go to General Linear Model. Now, here's why I've been taking you to General Linear Model instead of ANOVA so far. Because you can't go to ANOVA for this. You have to go to General Linear Model for this, so we just go to General Linear Model all the time. Now, we said it's not univariate. Everything we've done so far with ANOVA has been univariate. We said it's multivariate. And if I click on that and I open up a window and I get my boxes on the left and the right, we're going to see a little bit of a difference. So I've got a big box on the left with all the variables. I got some boxes plural on the right. Can you see what's different about this one that was not true about the univariate one? What's different? Not the one I'm looking for. By the way, that's the next procedure, by the way. Look at the very top. What is different about the dependent variable box? It's bigger, yes. Before we had room for only one variable. The multivariate option gives us more room to put dependent variables in because multivariate means you've got more than one. Our fixed factor is the same. We have room for more than one, which means, yeah, if we wanted to, we could do a two-way Manova. I don't want to, but we could, and you might want to. Maybe later. If you do, I'll help you with that. But for now, we'll stick with just a one-way multivariate analysis of variance. So, our study group is the fixed factor. Now remember, fixed factor is used interchangeably with independent variable. And it's pretty much always in the same place, or I think it always has been so far, that second box. Fixed factor, independent variable, sometimes they call it grouping variable. Those all mean essentially the same thing for the way we've used them so far. So it says dependent variables, plural. So that's where the other two things go. The difference between a two-way ANOVA and a multivariate ANOVA, a two-way ANOVA has more than one of these fixed factors. A multivariate ANOVA has more than one of these dependent variables. Okay, correct. All right, so next thing let's do, and by the way, I am just going step by step. Those steps are on page 226, and I'm going to pause a couple of times because while we do basically the same thing, there are a couple of twists we need to turn, like I just said. So we have done, I think we've done everything through number 5. Actually, no, we actually done everything through. We haven't clicked options box, so I want to click options box now. Now I have only one choice for what to display means for, and that's the group. Notice that only gives me a choice of independent variables. I just have one now, so I'm going to put the group from the left to the right. Down here I want descriptive statistics, and that's the means and standard deviations of all the groups. I want effect size, that's the eta squared. And I want homogeneity test, which again, that'll come into play more the next procedure than now. But for now, let's just go ahead with that. Here's the first twist. We're looking at this as a 0.05 level of significance, right? And we've always used pretty much the 0.05 level of significance. However, that 5% chance of rarity had to do with only one dependent variable. Now that we have two, we're going to have to adjust that. So, if we're going to test beginning with the 0.05 level of significance, we're going to have to split that between the two dependent variables, which means we've got to take that and divide it by 2 and get 0.025 that we want to change this to. So that's the first twist. And the second twist is going to be a little bit like this too later. Okay, quit. So I'm going to change 0.05 to 0.025. Divide your significance level by the number of dependent variables. I think it makes sense to think about it that way, but it's easy to forget. We've never done that before. Well, we've never had more than one dependent variable before. The book actually leaves out a step. The book doesn't say to click continue, otherwise you can't do the next thing it does tell you to do. So if I click continue, and if you harken back to the golden days when we first talked about ANOVAs, we always selected a post hoc. Now in our last procedure we held off on this a little bit, but when we first started doing ANOVAs, we went ahead and set up the post hoc. So I'm going to select post hoc, And again, I have to move my group over again. Normally we selected the 2-key follow-up test. This time we're going to select the Bonferroni test. Or as one of my early students said, the beefaroni part. So something like beefaroni and LSD going well together. I don't know about that, but Bonferroni has to do with dividing significance levels by, in this case, dependent variables. Sometimes if you've got like just an aside issue, another application of the Bonferroni approach is that if you've got a bunch of null hypotheses, and you've got a 1 out of 20 chance of being wrong and rejecting a null, the more shots you have at that, the more likely you are to be wrong. So in that case, it has to do with dividing your significance level by the number of null hypotheses. But anyway, Bonferroni because we're dividing by, in this case, dependent variables. The equivariance is not assumed stuff. Again, that has to do with, I'm not going to worry about that right now, so we're just going to go ahead and assume the equivariances. We've talked about that a little bit, so we're just going to stick with that for now rather than muddy the water too much so you don't overly drown. If I click continue, I'm ready to click OK, and that'll give me an output window. I'm looking for comments or questions, not seeing any, so I'm going to go ahead and do that and get an output window. And I'm going to get, let me just warn you, I'm going to get a messy output window. I got the output, I ran this by hand, well not by hand, but I did it and printed out hard copy, the output window, and here's the output window. And that doesn't even include the graphs, which we'll talk about in a minute too. So the key thing, as we said a number of times before, is, okay, what in the messy output window is important? So let's get that output window and let's start weeding through the mess. Let's just start looking at what we have. The first thing tells us that between subject factors, we have 3 groups. Study groups, group 1, group 2, and group 3, the think, write, and talk group. There's 10 of each of us. Well, we know that, but it's nice to see it because, you might want to have that counted for you. And then for each of the output, we have the means of standard deviations reported for us. So on the recall exam, I've got data for the 3 groups. On the application results, I've got data for the 3 groups. So because we have 2 different dependent variables, I've got 2 sets of means of standard deviations. Scroll down to where it says multivariate test, and again, I can only show so much on the screen at one time. The first important thing we want to look at is the line that says under group, and you'll see some of the numbers. The numbers are fairly similar, but this is the one we're going to choose to use. Just gives us kind of the same information, just according to a couple of different ways. We're going to look at Wilks lambda. Notice the Wilks lambda in these two columns. These 2 columns have to do with Wilks lambda. It has a value. Notice that I have an F value, and notice I've got degrees of freedom between groups and within groups. Remember the ANOVA gives us 2 different kinds of variances and 2 different kinds of degrees of freedom between groups and within groups. And I've got a significant value, which is our p-value. Notice it is significant because it's less than 0.05. So if you look at the value for Wilks lambda, by the way, Greek letter for lambda is, well, I'll show you. Kind of an inverted V. So the value for Wilks lambda, and you'll see it's written out right about 2/3 of the way down on page 227. And it looks like we normally report ANOVA information. It is, it's an F value, because notice our F column here. And notice our degrees of freedom, 4 and 52. There's the 4, there's the 52. That value, this is a parentheses, by the way, and I know I can't write any better. This intensifies my bad writing as it is. The value is 7.028. They call it 7.03. Comes from there. What do I say about the p-value? I can't say 0. I have to say less than, because p is never 0, because, again, the p-value, that's the probability of being wrong if you reject the null. So the p-value is less than 0.001. And my eta squared value is 0.351, or they probably round it off to 0.35. Yeah, they do. So there's the first piece of information. This is like when you stop the person on the street, you say, "Do you know what time it is?" And he says yes. And then you say, "Okay, what time is it?" And he tells you the time. Well, there's another question after that in this case. So far, we've got to the question where he says, "Yes, I know what time it is," because this is significant. That means I'm not finished. If it wasn't significant, I'd be finished. There was not any significant difference between anything. But there is, because of my low p-value. Not the first time I've said that, because that's always, regardless of what test, that always is indicative of whether we have significance or not. By significance, in this case, I'm meaning, is there a significant difference between some mean and some other mean? So far, so good? Let me point out to your attention one more thing they say about this eta squared. Look at the last sentence, just to remind you what this means. This is a measure of effect size. Doesn't use that phrase right here, but it will in another place in a minute. The eta squared, I mean, remember that squared. Remember the eta squared, remember the r squared? That told you something about how much variability is related to how much variability in the other place. So the way to say this, 35% of the multivariate variance of the dependent variables is associated with the group factor. That means it has to do with 35% of the variance. So those are the words you would use in a write-up. Just cookbook it out of there, copy and paste it. 35% of the multivariate variance of the dependent variables is associated with the group factor. Just means how much it has to do with it. Just something you report. Okay, so that gets us through the first table. You're still writing and typing. I'll wait. The one in your book is as good as the one I could come up with. If I wrote you another one, that would take away an option that you could write about. The point was made that we don't have a separate example of a Manova. And the one that they started on the bottom of page 229, where I was just reading from the first paragraph, that's as good a one as I could come up with. So, no, I don't have another one for you. Yeah, it's under an APA results section on page 229. So you can't write this one up, it's written up for you. So overall, what we've said so far, there's overall significance somewhere. That's nothing new because that's our first question anyway. So we get that from the Wilks lambda line, or the row. Now, the second paragraph of the write-up, since you brought that up, I'll just say it that way, is going to have to do with the next part we want to look at. I'm going to have to scroll down. Okay, I tried it both ways. It still takes a picture. If you look at the test of between subject effects, it's the next kind of big table. You got to skip over a smaller one to get there. We want to pay attention, special attention to, I'm going to scroll up a little bit, give myself more room. These two lines. And if you've got that in your book, you might want to do what I did, just make that notation in your book. Group and error. Well, we've looked at group and error lines before. It's just that now I've got more than one line for each of them. I've got two lines for each of them. I've got a line for recall, and I've got a line for application. Now, if I look at recall first, I'm going to look at these two lines. So I'm going to report that my F value for my degrees of freedom are the first two and the first 27. And the numbers happen to be the same here, but they may or may not be in all cases because you may have different size groups. So F4, where'd it go? Okay, right, there we go. So F4, 2 and 27 degrees of freedom, that F value is the F value by the recall, 17.111. And what's my p-value? Less than, it says 0, but I can't write p equals 0, less than 0.001. Does that indicate significance? Yes, there is significance for recall. We'll deal with that in a minute. The other part of this is my eta squared is 0.559, so it's approximately 56%. Okay, question, oh, screen gone, okay. My screen's gone, let me go back and, it disappeared, I thought I got it back, but let me go back and see. Okay, there it is. Should be there now. Of course, all my markings disappeared, but that's okay. I'll say that again. Okay, so looking at group and error, we've got both recall and application for both places. So if I'm looking at recall first, well, am I touching anything? No, it went away again. on your screen yet? No? Okay. All right. Let me try something else. Still not? I know. Yeah, when I don't know what I leaned over. I didn't think I touched anything, but apparently I did. Okay, let me back out and start again. Okay, I don't know what's going on here. Obviously, that's what I want to go on is not going on. Sorry if you're watching the recording, but I cannot pause this without starting another file. So you're going to have to watch me work through this. I think I'm onto something. Okay, there it is. Okay. Okay, don't touch anything good. Group and error. For recall. 2 and 27 degrees of freedom respectively, so for recall. F of 2 and 27. The F value is 17.111. The P value is, we said, even though it shows it is 0, we have to say P is less than 0.001, and the N squared is 0.559, which indicates about 56% of that variance associated with the group stuff. Okay, and we said there is significance for recall because the P value is low enough. Agreed? I think that's the last important thing I might have said in life. So the recall is significant. That means we got to report specifically on recall in a minute. Let's do the same thing for application. Question? Oh, okay. Okay, what was your question? Okay, I'm not seeing you type. Okay, yeah. Did someone have a question? Type it in if you do. It's not here though. It's not frozen here. Okay. I am stuck. Now I'm stuck here. Okay. All right. I've taken the screen away with you. The question is, do we always write recall in front of the F? Yes, you do. You do for that one because we've also got to do it for application. And I've not written that for application yet. That's the second F value I reported. You remember the first one was for the Wilks lambda in the previous table. So we still got to do one more. So the other thing we want to look at is, okay, we're looking at these two parts. I want to look at the application. So for application, I'm going to have an F value of, again, 2 and 27 degrees of freedom. Notice they're not the same 2 and 27. They're the same numbers, but they come from different places. They come from the 2 by application for group and the 27 by application for error. So this 2 and this 27. So that F value is equal to 4.2. And that p-value is equal to 0.026, and the eta squared is 0.237. So, is anything in application significant? It's not a trick question, but it's a loaded question because we have to get below not 0.05, we have to get below 0.025, because remember, we had to divide that initial significance level by the number of dependent variables. So we kind of set a lower bar, so to speak, which in this case is more difficult or less likely to reach. So, in this case, this is not significant for application because it doesn't go below the alpha level we're using as the yardstick or the measuring stick. We've got to get below 0.025. So recall is significant, application is not. When you look at the write-up, let's refer to the, okay, there we go again, and I wasn't even looking at it right. Well, look at the second paragraph of the write-up. And the wording is, I'm just going to insult your intelligence by reading this to you since my screen disappeared again. Analysis of variance on the dependent variables, plural, were conducted as follow-up tests to the Manova. Using the Bonferroni method, which is why we click that one, each ANOVA was tested at 0.025 level. Why do we say 0.25? Because we had to slice it in two because of the number of dependent variables. The Manova on the recall scores was significant, and that's that first F statement I wrote. And then the p-value is less than, they rounded less than 0.01. That's significant. But then the last thing we wrote, the ANOVA on the application scores was not significant because the p-value, and it's again that last F statement I wrote, the p-value is not less than 0.025. So the only thing we have to follow up on the follow-up is just the recall. Let's see if I can find that back on the screen for you again. Do we write Wilkes in front of it? Yes, you write Wilkes in front of the first one because you'll notice that in the first paragraph they did write the Wilkes lambda there. So the first paragraph you report the Wilkes line. The second paragraph you report on the two different dependent variables. And the third paragraph we're going to report on the dependent variables that are significant, which in this case is only the one, just the recall. The first paragraph, again, the write-ups have three paragraphs. The first paragraph, something happened there. Okay, there it is again. Okay, I'm on the bottom of page 229, three paragraphs for the write-up. The first paragraph reports on the Wilkes score. Let me be deal with danger, see if I can point that out. Right here. That's what the first paragraph reports. If it's significant, you got another paragraph to write. If so, if the Wilkes is significant, we report on both the recall and the application to see if there's significance within either recall or application. We found out that there is significance on recall, there's not for application, so that means we have to write a third paragraph on the recall. So we're 2/3 of the way there. question was if they're both significant, you have a fourth paragraph. No, the third paragraph takes care of whichever significant. I've got a question to write the application F again. Okay, the application F is disappearing again. Hang on. I don't know why things are disappearing all the time, but I will try to bring them up again. Still not on your screen, is it? At home? Okay. All right. Bear with me, please. Appreciate your patience. Okay. Okay, the request was to write the application part again. So for application, I'm going to look at the application part for these two parts, and the application comes from here and here. F of this 2 and this 27 degrees of freedom is equal to the F value, and the F value is the last one, it's the last one of the F column beside application. 4.20. T is equal to 0.026, and a squared is equal to 0.237. But that 0.026 is not significant because it doesn't go below the 0.025 that we normally look for. Well, it doesn't go below 0.025 that we look for in this case. Okay, so at this point, we have to write a third paragraph because recall is significant. So I scroll down at great risk because I know this thing's going to disappear on me. See if I can make this a little larger for you. Okay. So on my multiple comparison section, I've got the recall part and the application part. I don't need that. So I can ignore the application part because we said that's not significant. So for the recall part, that's the only part I need. I'm going to compare think and write, think and talk, and write and talk. Anything else I didn't connect is just duplicate information. Talk and think is the same as think and talk. I look at my significance levels here, here, and here. Now I told you there's one more little twist that comes into play. Where is it? If you look at the significant levels, remember we were going with that 0.025 level because we divided it by the dependent variables? I need to take that 0.025 and now divide it by the three groups we have. And that's going to end up with approximately 0.008. I can say it again. I don't know if I can show it again. divide my 0.025 by the number of groups we have. He says very frustratingly. Close. Okay, all right, here we go. So, think right, think talk, right talk. My 0.025 divided by the three groups. I'm looking at p-values below 0.008. So, think right is, think talk is not, right talk is. So for the recall exam, there are significant differences between the think and write and the write and talk. So what that, I could paraphrase that. I could paraphrase that, that's okay, to say that for the recall exam, there's a significant difference between the writing group, and each of the other two groups. I tried to say that fast before it disappeared again. If you're watching the recording, you can pause it, thankfully, and pretend I didn't lose it or it didn't go away on me. Significant difference between the writing group and both the other two groups. Because the writing is in both, yes. So look at what it says in the third paragraph. Again, I'll insult your intelligence again because I'm disappearing all over the place, so I'll just say it for you. Post hoc analysis to the U of A and ANOVA for the recall scores, because that was a significant one. For the recall scores consisted of conducting pairwise comparisons to find which strategy affected, I'm not crazy about the word effective, but okay, performance most strongly. Each pairwise was tested at the 0.025 level divided by 3, or the 0.08 level. 0.008 level. The writing group produced significantly superior performance on the recall questions in comparison with either of the other two groups. Writing was significantly higher than the other, and then there's a table we're going to refer to on the next page where you've got to construct that too. The thinking and talking group were not significantly different from each other. Whew, that takes us through the narrative of the APA right up finally. Let's look at the other page, though, because there are two things we need to do. We'll look at this box plot, and I'll come back to that in just a second, but let's look at the table we referred to just a minute ago. They're giving means and standard deviation for both the recall and the application data. And that comes from way back at the first part of the printout when we asked for that descriptive data information. Way back, and it just... Do I need to go back and find that again? don't make me. The ones in descriptive statistics, yes. Hang on, I'll find it again. Yeah, compare the table in your textbook with this information. table and this is part of the APA write-up, the table at the very end of the APA write-up on the bottom, about two-thirds of the way down, comes from this stuff. Thinking had a mean of 3.30 and a standard deviation of 0.675. They rounded it down actually. That's where that first data comes from in the left column. So you're just going back and reporting the means and standard deviations for everything. Well, you get the information there, but again, on the write-ups, I mean, don't give me a copy and paste from the output in SPSS other than the box plots. I mean, SPSS gives you a bunch of tables. Don't just copy and paste the tables. Make your own table according to the format you're asked for here. We've not asked for it yet. That's all I said to go back to. Okay, so you also need a box plot since you brought that up. Thank you very much. Go back to page 228, and it tells you how to use SPSS graphs to display the results. And I don't think there's anything different than the way we've done that before, but let's go through the steps according to what they say. We're going to go to graphs. Get rid of all the ink stuff there. Go to legacy dialogues. And we're going to do a box plot. Here's what's different. This time we will do clustered. We'll do something different. And summaries for separate variables. Clustered and summaries for separate variables. And it says that at the very bottom of page 228 if you forget which of those to choose. We click Define. Group goes to Category Axis. And we're going to put, and this is kind of easy to remember because there's only one place you have room for more than one. So recall and the application goes for what the boxes represent. So there's really kind of only one way you can do this. Although I can mess it up if you prefer, but. And when I click OK, I should get my box plot at the end of the old output window. And I'll scroll down and find that. It's still thinking about it and processing. And there it is. And that's what you can copy and paste this from your SPSS output, but not the tables and the charts they give you. Okay, so that was a long-winded way of working through one problem. Question, comment, thoughts? Okay. If we're okay, then we're okay for now.